I'm Rachel Neiman, and this PowerPoint presentation is on muscle oxygenation and fatigue during high-intensity interval training, a comparison of dominant and non-dominant lower limbs. Fatigue during high-intensity interval training has been found to be caused by decreased muscle activation of the working muscles and increased co-contraction of antagonist muscles, causing a lack of synchronization between agonist and antagonist muscles. Muscle oxygenation in relation to fatigue has become a topic of investigation with various conclusions. It has been found that type 2 fibers are activated under reduced oxygenation conditions and are more susceptible to fatigue than type 1 fibers. Replenishment of phosphocreatine during recovery is also vital for repeat sprint performance and is dependent on oxygen. Comparisons of dominant and non-dominant legs have been used in assessments of contralateral imbalance and the risk of injury with various results. To further investigate the role of fatigue and performance decrements, comparisons of dominant and non-dominant legs may provide more information. Different levels of fatigue or oxygenation in contralateral limbs may increase the risk of injury. Therefore, the purpose of this study is to compare fatigue and oxygenation of the dominant and non-dominant legs during a high-intensity interval training protocol. The hypotheses are that fatigue is related to muscle oxygenation, sprint fatigue is related to muscle deoxygenation, and that there will be a difference between dominant and non-dominant legs in muscle oxygenation and power output. 8 exercise and sports science students volunteered to participate, including 5 males and 3 females. All participants were right leg dominant. The study design was descriptive cross-sectional, and the key outcome measures were the muscle oxygenation responses of each leg, the peak power output across each sprint interval, and the percentage of power output of each leg. Before the cycling protocol began, a 5-minute warm-up was completed. The protocol consisted of a warm-up of 4 rounds of 10 seconds at 80% maximal effort with 20 seconds recovery. This was followed by resting the legs for 3 minutes before the high-intensity interval training protocol began. This consisted of 10 seconds at maximal effort and 20 seconds of recovery for 8 rounds on a combined cycle ergometer. Muscle oxygenation was measured using near-infrared spectroscopy. This involves the proximal tissue oxygenation and blood flow being measured by probes emitting light at near-infrared ranges within 2.5 centimeters of the skin surface. Probes were placed on the vastus lateralis and medialis on each leg, and the sampling frequency was set at 2 Hz. Relationships between deoxygenation during sprints and fatigue, reoxygenation during recoveries and fatigue, and deoxygenation and reoxygenation were tested using Pearson's product moment correlation. Contralateral limb differences were tested using independent t-tests and included the average deoxygenation during sprints, average reoxygenation during recoveries, and fatigue. The differences across sprints and recoveries in each leg were tested using paired t-tests. They included peak power, deoxygenation, and reoxygenation. The mechanical measures of power output and fatigue. It can be seen that there was no significant difference between dominant and non-dominant legs, either for fatigue or peak power during sprint 1 or sprint 8. There was a significant loss in power across sprints in both the dominant and non-dominant leg. Again, there was no difference in physiological measures of muscle oxygenation in either the dominant or non-dominant leg. There was a significant or near to significant decrease in oxygenation during across sprints in both dominant and non-dominant legs, and a significant difference in oxygenation during recoveries in the non-dominant leg, but not the dominant leg. There was no significant relationship between oxygenation and fatigue for either leg. This graph shows a strong correlation between oxygenation, deoxygenation and reoxygenation in the dominant leg, and the same for the non-dominant leg. As expected, a significant reduction in power was found across the sprint intervals. No contralateral imbalance was seen for fatigue measures. This could possibly have been due to the contralateral crossover of fatigue by the CNS, which may increase the coordination of limbs, reducing the risk of injuries. It may also be because the protocol involved maximal intensities. Asymmetries seen at low or moderate intensities have been seen to disappear at maximal intensities. Fatigue was not related to deoxygenation during sprints. This may have been because reduced oxygen transport leads to the activation of type 2 muscle fibers, which function under anaerobic conditions. Fatigue was also not related to reoxygenation during recoveries. This may have been due to insufficient phosphocreatine being resynthesized from oxygen in the short recovery interval of 30 seconds. However, it must be noted that due to the sample size being small, the otherwise moderate correlation was deemed to be insignificant. No contralateral imbalance was seen for deoxygenation or reoxygenation during the cycling protocol. Oxygenation across sprints decreased by 60% in the dominant leg and 75% in the non-dominant leg. Oxygenation across recoveries decreased 49% in the dominant leg and 66% in the non-dominant leg. The decrease of 49% in the dominant leg was found to be not significant, but this may have been because of the small sample size causing a type 2 error. In conclusion, power output and oxygenation measures in dominant and non-dominant legs were not significantly different. Investigation at low and moderate intensities may provide more information about the difference in oxygenation and fatigue in contralateral limbs. Muscle oxygenation cannot be ruled out as a determinant of repeat sprint performance. The indication that muscle oxygenation may not cause fatigue has practical training implications. A greater understanding of fatigue mechanisms may benefit athletes participating in sports with repeat sprint intervals. Thank you.